How AI impacts skill formation. That is the paper we're breaking down today. It's from Anthropic by Judy Hanwen-Shen and Alex Tamkin. And we are just going to start with the punchline because the results here are,
Yeah,
well, they're pretty aggressive.
they really are. The researchers set up this fantastic experiment to answer one very specific question. If you use an AI assistant, like ChatGPT or Copilot, to do a task with a new tool, do you actually learn that tool?
Or are you just renting the competence for a few minutes?
Exactly.
And the answer was a pretty hard no on the learning part. Participants who used AI scored 17% lower on a follow-up quiz.
17%. I mean, that's roughly a 2-letter grade drop. It's significant skill loss.
Wow.
But here's the bit that really shocked me. You usually assume there's a trade-off, right? You trade learning for speed.
Sure. I might not get it, but I shipped it fast.
Right. But this paper found zero. And I mean zero statistically significant improvement in task completion speed for the AI group.
Wait, hold on. Let me get this straight. They learned significantly less,
Right.
and they weren't any faster.
Correct. The productivity paradox, it's real. Turns out all that prompting, reading, verifying the code, it has this massive interaction cost that just eats up the time you thought you were saving.
Ugh.
But, and this is a really key point, it wasn't all bad news. They did find some specific interaction patterns, like user personas, that did manage to learn effectively while using the AI.
So it's possible.
It's possible, but you have to actively fight that path of least resistance.
Okay, that's the summary. Now let's really get into this, because as someone who stares at VS Code all day, this feels
Yeah.
very personal. Let's talk methodology, because usually these studies are just, undergrads doing leak code problems. Was this actually like real engineering?
It was much, much better than your standard academic setup. They had 52 participants, and the demographic mix was really solid. You had people with 1 to 3 years of experience, all the way up to folks with 7+ years, mostly professional or freelance devs.
Okay, so people who actually get paid to ship code.
Exactly. And the prerequisite was key. You had to know Python, be comfortable with the language, but you could not know a library called Trio.
Trio. Okay, I've used Asyncio, I've done threading, but I have not touched Trio.
And that makes you the perfect candidate for this study.
Mm.
Trio is an asynchronous I/O library. It handles concurrency, but it has its own way of doing things, very different from Asyncio. It uses something called structured concurrency.
Oh, right, the nursery concept, where you open a nursery, spawn tasks inside it, and it guarantees they all complete before you move on.
Look at you, you've done the reading.
Yeah.
But yes, that's the core idea. It requires a specific mental model. You can't just guess your way through it.
So it's a great proxy for learning a new tool on the job.
A perfect proxy.
Okay, so you have 52 devs. They all know Python, none of them know Trio. How did they set up the experiment?
It was a standard randomized control trial. First, a warm-up task, just basic Python, no AI, to get a baseline skill level. Then the main event, a 35-minute task. They had to write a script using Trio to implement a timer and handle some data retrieval.
And the split, the two groups.
Right. The treatment group got access to Cosmo, which was basically a GPT-4o assistant, and the instructions were very clear. Use this tool to speed up your workflow.
So they were priming for productivity. Go fast.
Totally. Move fast and break things. And the control group,
Let me guess. Just the docs.
just the official Trio documentation and a search bar.
Yeah.
No LLMs, the eat your vegetables approach.
That sounds painful if you're used to Copilot.
It is. But here's the kicker. After the 35 minutes, boom, time's up. Everyone takes a quiz. Debugging problems, code reading, conceptual questions about how Trio works, and, critically, no AI allowed during the quiz.
Training wheels come off.
Completely off. Can you actually solve this problem with just your own brain?
Okay, let's go back to that speed number because I'm still stuck on it. No significant difference in time. If I asked GPT-4o to write a Trio script, it spits out code in, 10 seconds?
It all comes down to what they call interaction cost. They logged everything. The control group, the manual readers, they averaged about 24.5 minutes.
Okay.
The AI group averaged around 23 minutes. The p-value was 0.391.
So that's just noise. Statistically, it's the same.
It's nothing. And when they watched the screen recordings, they saw where all that time went.
Yeah.
It wasn't in writing code, it was in writing prompts.
People just fiddling with the query forever.
Fiddling is a polite way to put it. They found people spending up to 11 minutes of the 35-minute session just writing and editing their prompts.
11 minutes. That's a third of the entire time.
There was one person who spent 6 full minutes on a single prompt, just refining it, adding constraints, trying to get the phrasing perfect.
See, that is the prompt engineering trap. You think you're saving time by not coding, but you're just programming in English, which is an awful, ambiguous programming language.
You're shifting your effort from cognitive coding to, well, linguistic negotiation.
Yeah.
You're basically arguing with a bot.
But surely some people just copied and pasted. That has to be faster.
Oh, it was. They called those the direct pastors. And yeah, they were the fastest group. But as you can imagine, their quiz scores were in the basement.
High speed, zero retention.
Right. But then you had another group, the manual copiers. These are people who got the AI code, but then retyped it by hand into their editor.
I know so many people who swear by this. The theory is the muscle memory helps you learn it.
It's a popular theory. The data here says it's a myth. The manual copiers were just as slow as the control group, obviously, but their quiz scores were no better than the people who just pasted it.
Really? So the physical act of typing added nothing?
The paper calls it mindless transcription. You aren't processing the logic. You're just a very slow biological photocopier. You're looking at characters, not concepts.
That is just devastating for the I type it to learn it crowd. Okay, let's get to the learning loss. That 17% drop, where were they failing? Was it just syntax?
The biggest gap, and the one that should probably worry engineering managers the most, was in debugging.
They couldn't fix broken code.
You couldn't even figure out why it was broken. And this goes back to the experience during the task. The control group, they hit a lot of errors, a median of 3 errors per person.
Right, because with Trio, you have to await things. If you forget, it throws a runtime warning.
Precisely. So the control group would write code, see that warning, go, what? Check the docs and realize, oh, I have to await this. That whole loop, try, fail, diagnose, fix, that is learning.
Its struggle is the entire point.
And the AI group, their median error count was 1. The AI just wrote correct code on the first try, most of the time.
So they only ever saw the happy path.
They lived on the happy path. They never saw a runtime warning. So when the quiz showed them code missing in await and asked, what happens now? They had no mental model to fall back on. They were just guessing.
It's the GPS effect. You follow the blue line on Google Maps for 5 years, and then one day your phone dies and you realize you don't actually know the city at all.
And in software, knowing the city is debugging. Seniority isn't about writing code faster. It's about having this huge internal database of what can go wrong. The AI users weren't building that database.
This all sounds pretty grim. Like, the conclusion is just don't use AI if you want to be a good engineer. But we can't really do that.
No, and the paper doesn't suggest that. In fact, this is where the study gets really valuable. They looked at the recordings to find out who actually succeeded. And they found 6 personas, 3 that failed and 3 that actually learned just as much as the control group.
Okay, lay 'em on me. Let's start with the failures. How do I not use AI?
Well, we already talked about AI delegation, the copy pasters. The second one is progressive AI reliance.
What's that look like?
That's the I give up persona. They start trying to do it themselves. They write a few lines. They hit a bug. They get confused. And after like 2 minutes of struggling, they just get frustrated, delete everything, and tell the AI, just do it for me.
That is painfully relatable. The bailout.
Yeah, it is. But the moment you bail out, the learning just stops cold. But the third failure mode is maybe the most dangerous. Iterative AI debugging.
Let me guess, that's when you just paste the error message into the chat.
Over and over and over. Your code crashes. You don't even read the stack trace. You just copy the error, paste it to the bot, say, fix this. It gives you new code. You paste that in. It crashes with a different error. You paste that one.
You're just a middleware layer between the compiler and the LLM, the flailing loop.
Exactly. You aren't building a model of why it's failing. You're just trying to brute force a solution. And these users, of course, scored the absolute lowest on the debugging quiz because they had trained themselves to ignore error messages.
Okay, so that's the graveyard. Who are the winners? Who used GPT-4o and still got an A on the test?
These are the really fascinating ones. The first high-scoring persona they called conceptual inquiry.
So asking questions, not asking for code.
Yes. They treated the AI like a senior dev sitting next to them. They'd ask, how does a nursery scope actually work in Trio? Or, explain the difference between start soon and start.
They get the concept, then they write the code themselves.
Mostly, yeah. They use the AI to build the mental model, not to perform the labor.
That takes a lot of discipline. When you're on a deadline, it's so tempting to just ask for the code.
It takes massive discipline. The second group, hybrid code explanation. Their prompt would be something like, write a function that does X and D, explain step by step how it works.
So they force the AI to show its work.
And this is the critical part. They actually read the explanation. The screen recordings showed them highlighting the text, mapping the explanation back to the lines of code. They were actively engaged.
And the third group?
Generation, then comprehension. These users would generate the full block of code, maybe they were in a rush, but before they moved on, they paused. They just sat there for a minute and read the code the AI wrote.
Like a self-code review.
Exactly. And sometimes they'd even ask follow-up questions about it. Why did you use move on after here instead of fail after? They were verifying the logic.
So the common thread for all the successful users, it seems to be cognitive load. The people who failed were trying to offload all the thinking. The people who succeeded were using AI to augment their thinking.
That's the perfect way to put it. The researchers call it intentional cognitive effort. You can't learn passively. Learning is an active process. If you aren't mentally sweating a little bit, you're not encoding anything.
Which brings us to the lazy factor. Did the AI users know they weren't learning, or did they feel like they were crushing it?
This is the illusion of competence. Both groups, AI and control, said they enjoyed the task. But the AI users felt more productive. They felt the task was easier.
Because it was easier. They got to skip the struggle.
Right. But when you asked them, how much did you learn? The control group reported significantly higher scores.
Yeah.
And the AI users, they knew. One quote from the paper was amazing. I didn't read the trio library intro as closely as I would have otherwise.
They knew they were skimming.
They knew they were being lazy.
That is the danger zone. It feels good, it looks productive, but it's just hollow.
Yeah.
So, zooming out, what does this mean for the industry? We're seeing this huge push for agentic workflows, Devin, agents that can build entire features.
If this paper is any kind of signal, that trend is terrifying for skill formation.
Right. If an agent writes the code, runs the tests, fixes its own bugs, and deploys, where does the human learn anything?
They don't. And you build up this knowledge debt. You might hit your Q1 targets with a team of juniors using agents. But in Q3, when the system had a weird, complex bug, nobody on the team has the mental model to even understand the system they built.
And even for seniors, if your job just becomes reviewing AI code, does your own skill start to atrophy?
It has to, right? You lose the nuance. You might spot a syntax error, but will you spot a subtle race condition if you haven't actually wrestled with that library yourself in months?
So what's the solution? Do we need to build some kind of study mode into our IDEs?
I think we genuinely might. Imagine a setting in VS Code for learning mode. You tell it, I'm learning Trio today. And now if you ask Copilot for code, it refuses. It says, I can't write that for you, but here's a link to the docs for the nursery object. Try it yourself, and I'll give you feedback.
A Socratic AI. That would be both incredibly annoying and incredibly valuable.
It's about engineering desirable difficulties back into the process. We've spent a decade trying to remove all friction, but turns out the friction is where memory is made.
That is a really powerful thought to end on. If you optimize your workflow for zero friction, you might be optimizing your brain for zero retention.
Efficiency is not the same thing as competence.
The paper is How AI Impacts Skill Formation. It is a massive wake-up call. And please, read the actual paper. Don't just ask an LLM to summarize it for you, because apparently you won't remember a thing.
Hard truth.
Thanks for listening. Keep your skills sharp, and we'll see you in the next one.